Good morning, everyone. We are Chen Liu and Ayapa to present database security. We'll give our presentation in the following parts. First of all, we'll introduce what is database security and give specific examples. Then we'll talk about the risks that a database would face and the common methods to ensure database security. Database security concerns the use of a broad range of information security controls to protect databases against compromises of their confidentiality, integrity, and availability. It involves various types of categories of controls, such as technical, procedural, and physical. There are three main concepts: confidentiality, integrity, and availability. Confidentiality means information should not be accessible to unauthorized users. It ensures that users are allowed to do the things they are trying to do. Integrity means data cannot be corrupt. Only authorized users should be able to modify the data. It ensures that what users are trying to do is correct. Availability means authorized users should be able to access the data reliably at all times.
Now let us talk about some of the risks to database security. Unauthorized or unintended activity. This can happen when someone is granted database privileges that exceed the requirements of their job function, or users may abuse legitimate database privileges for unauthorized purposes. Malware infections. Cybercriminals, state-sponsored hackers, and spies use advanced attacks that blend multiple tactics to penetrate organizations and steal sensitive data. Unaware that malware has infected their device, legitimate users become a channel for these groups to access your networks and sensitive data. Denial of service. Denial of service is a general attack category in which access to network applications or data is denied to intended users. One of the most common techniques used is to overload server resources such as memory and CPU, either by flooding them with excessive number of queries, resulting in resource-starved servers becoming unresponsive and in some instances even crash. Physical damage to database servers. This can be caused by computer room fires or floods, overheating, accidental liquid spills, static discharge, electronic breakdowns of equipment, or failures and obsolescence. Design flaws and programming bugs in databases. It is common to find vulnerable and unpatched databases or discover databases that still have default accounts and configuration parameters. Attackers know how to exploit these vulnerabilities to launch attack against your organization. Enterprise data security has become not only a major focus of attention in the tech industry, but has also become a concern for mainstream public. With the steady stream of data breaches at companies, many organizations are now beginning to appreciate the importance of data security and how much of a financial toll a hack can cause. A few examples of database security breaches that took place in the 21st century are Fidelity National Information Services. It was reported that the theft was discovered in May 2007 and that a database administrator named William Sullivan allegedly stole the data for an undisclosed amount to a data broker, who in turn sold it to various marketing firms. At Target, hackers had gained access through third-party point-of-sale payment card readers and had collected about 70 million credit and debit card numbers. That included full names, addresses, email addresses, and telephone numbers. The final estimate was that the cost of breach was about 162 million. Sony hack. This is viewed as the worst gaming community data breach of all time. One of more than 77 million accounts affected, 12 million had unencrypted credit card numbers. The hackers gained access to full names, passwords, emails, home addresses, purchase history, and credit card numbers. Let us see what are the common methods to ensure database security. First, access control. It is common that different users of a database have access to different objects of the database, and so a DBMS must provide mechanisms for regulating access to its objects. There are three types of access control mechanisms: discretionary access control, mandatory access control, and role-based access control. The word discretionary means to act in a way to avoid the revealing of confidential information. A user may be granted the privilege to access a certain object with a certain action. For example, read the object or modify the object. In this method, we can grant and revoke privileges to different users of the database. Mandatory access control provides multi-level security by classifying data and users into different security levels. Mandatory access control provides security for extremely confidential information. Role-based access control provides security according to the role of the user who is accessing the database. Role of the user is created using create command. Role gives permission to only authorized users to access the data, thus roles provide security in a smart and simple way. Protecting sensitive data, especially data at rest, from a malicious user such as an intruder or a corrupted employee can be achieved using database encryption. Encryption is the process of encoding messages or information in such a way that only authorized parties can read it. Encryption does not by itself prevent interception, but denies the message content to the interceptor. The purpose of encryption is to ensure that only somebody who is authorized to access data, example a text message or a file, will be able to read it using a decryption key. One of the disadvantages of encryption is the degradation in performance because of the time taken to encrypt and decrypt the data. Over the past few years, database encryption, both in the form of encrypting network data traffic as well as at-rest data encryption, have attracted much interest from database vendors, with Oracle coming up with its transparent database encryption solution to encrypt data both at the column as well as the table space level.
So the next method is integrity controls. Integrity controls protect data from unauthorized use and update. Often, integrity controls limit the values a field may hold and the actions that can be performed on data, or triggers the execution of some procedures, such as placing an entry on log to record which users have done what with which data. One form of integrity control is a domain. In essence, a domain can be used to create a user-defined data type. Once a domain is defined, any field can be assigned that domain as its data type. One advantage of a domain is that if it ever has to change, it can be changed in one place, and all fields with this domain will be changed automatically. And others and triggers can be used for security purposes as well. Another method is database backup and recovery. A database management system must provide mechanisms for backing up data with as little disruption of production time as possible and restoring a database quickly and accurately after loss or damage. A database management system should provide 4 basic facilities for backup and recovery of a database. Backup facilities, which provide periodic backup copies of portions of or the entire database. Journalizing facilities, which maintain an audit trail of transactions and database changes. A checkpoint facility by which the database management periodically suspends all processing and synchronizes its files and journals to establish a recovery point. A recovery manager which allows the database management system to restore the database to a correct condition and restart processing transactions. So that's all for our presentation. Thank you for your listening.